So, a lot of times, first of all, hello, it's been a little while, I know. A lot of times on this channel, I get asked, how can I improve my skills as an engineer? How can I stay sharp if I'm not working? My typical answer is, well, do some home projects. And then people ask, well, like, give me an example, like what kind of projects? And I don't usually know because I don't do very many myself. So I figure out, why don't we do a DIY project together? As you guys can see behind me, this background needs a lot of work. So what I did is I went and bought some LED lights that we're going to install in the shelves. May not seem like the most difficult project, and I guess we'll kind of find out, but it does involve a fair amount of drilling, soldering, and actually a lot of planning went into this. It's going to be a really good example for you guys and even for myself to learn how you should go about doing a project like this, and I guess we'll see if we succeed or not. So let's start building. Hold on there, sport. Before we start building anything, we need to define what our objectives are. So what is our main objective? It is to install LED lights on these shelves. Pretty straightforward. Next, we list out our requirements. Number one, I want lights on and only on these 6 shelves. I figured one strip of lights on each shelf should be good enough. Thus, if I measure the length of each shelf, I can figure out what the total length of light is that I need. Number 2, all of the lights must be in sync. These LED rolls usually come in sets of 2, which can both be connected to a common controller. So, one roll on this shelf and one on this one. This gave me an idea of how things were going to go together and how much wire I might need. Number 3, I don't want anything to be visible. When I'm filming, I don't want my audience to see the lights, extension wires, or anything else in order to preserve the aesthetics, if you will. Number 4, I need to have the lights in the front plane. One thing I've learned with filming is that you always want the light to be in front of your object, which in this case might be books or whatever I decide to put in there. This means that the light strips will go on the top underside of each shelf. Once that was done, I began researching and watching tutorials to figure out what I needed to buy. Got all the soldering stuff from my local hardware store, ordered all the lighting stuff online, and then I got to work. So the way that this is going to work is that this roll is going to be cut into 6 different strips that are going to be on the 6 shelves. Instead of just wrapping the whole, like this entire roll around each shelf and then to the next one, no, so each strip is going to be connected with the wires, with the conductor wires. That's why there's going to be some soldering. What I'm going to do is I'm going to drill a hole in the back here for each shelf. And the reason why is because I don't want these wires to be shown. We will first run up the wires through the back where you won't see. The wire is going to come in, connect to the LED. Then the wire from this end is going to run back out through the same hole and then up through the next one, through the back, through this hole, wire, LED, wire back out, and so on. Alright, that should be good. Each shelf is around 13 inches in height, and it is 11 inches deep across, almost 23 inches. So what did I say? 13, 11, and 23. 47 inches. Wow. This should be enough. And then about there. Perfect. What I'm going to do now is I'm going to cut these strips. So 6 strips of 20 inches or whatever. And then I'm going to solder the wires on them. This whole thing is going to be one giant rope. Like, it's going to be one assembly. Everything's going to be soldered together. So I'm going to grab the soldering stuff. I'm going to go to the garage and do the soldering. And I've never done soldering. I haven't done, well, I did soldering for one term maybe when I was, 10 years ago. But it shouldn't be that hard, but we'll see. So I watched a couple of really good tutorials on YouTube on how to, solder for beginners, and I'll leave those in the description. But this is basically what they recommended. So we got our soldering iron, our solder, flux, which I guess helps the solder basically adhere, wire cutters, Safety glasses, a sponge, some electrical tape, and then we have helping hands here. First thing, we're going to strip this wire that we already cut. All right, now I'm going to cut the lights. That's about right. Okay. I don't know what the best way to solder is. I've purposely not looked at tutorials for that because I wanna try and fail. Just gonna spread some flux. So I seen one method where the guy first soldered the solder to the wire and then soldered it to the light. That's not good. Oh, fuck. Boy, this is not easy. Oh, shit. Fuck. Okay, it's a nice blob. Fuck. Come on. Come on, come on, come on. Okay, well, I mean, that's not a great connection, but I mean, that definitely helps to put the solder on the wire first. Fuck. That's hard. We're gonna try this tomorrow. Well, back for another day. So I guess soldering is not that easy. So we left off basically trying to solder our first joint, and I'm pretty sure that I just cooked this guy. You can see it's burnt pretty bad. So I gotta be a little more aware of not just completely melting the light itself. This time we're going to solder, and I looked this up. Guy was saying just put some solder on here and then connect each wire. So we'll try it that way. Look how it just adheres, like it almost like it's like a magnet or something. Man, Jesus. Okay, let's try this, please. Come on now. Fuck. So, this is our first joint. Looks pretty awful. I don't know if it works. We'll find out when we do when we connect the other end. Man, this is a lot tougher than I ever thought it would be. Wow. Well, and this one's not even on, so actually we have to redo that. Wow. Another day. And now a word from today's sponsor. Do you guys like writing resumes? Because I don't. Writing a resume can be a long and downright painstaking process. That's why you should use Beamjobs. Beamjobs lets you build custom resumes suited to your profession. With an abundance of styles, they can get your resume looking exactly how you want. Beamjobs has dozens of different careers to choose from and literally hundreds of examples of content to help get you started. They also provide custom feedback tips. For example, you should only add projects if you're light on relevant work experience or if it's something significant, which is something I've even said in my videos. I always recommend that you first try and build a resume on your own, but I think a guide can be very helpful if you're just getting started or if it's been a few years and you need to freshen yours up. With over 20,000 resumes created each month, Beamjobs can help you get exactly the job that you want. Click the link in the description below to get your resume professionally done today. Now back to the video. All right, we're back for day 3 of the soldering adventures. So, a couple things this time that should make my life a lot easier. One, I got a thinner solder. This is a 1/16 of an inch as opposed to an 1/8 of an inch, which I was using before. Look how massive that is. No wonder why I was having problems. And number 2, I got a new solder, which it's kind of like the old one, it just has a finer tip. So that should make things a lot easier this time. Oh yeah, that's much easier. Okay. I was watching a couple of videos and they said, all you gotta do, just press it on there. Kind of weird, eh? It's just like intermittently flashing. So maybe it has to be connected to the other end. I don't know. I'm supposed to be an engineer. I should know this. And wouldn't it be nice if this thing worked? So, from what I just read, I probably have a cold solder joint, meaning that the solder did not properly form, thus it's creating a lot of resistance, I think. I'm gonna try and make this a little bit more finer. Oh, okay, there we go. Look at that. That is really cool. So it was the solder. I'm pretty stoked right now because this is gonna work. What do you know? Okay, so we have another problem here. The wires that I've installed have added way too much resistance. And so what happens is this. Now I didn't think about this when this is such a good DIY project for this reason. I never thought about the resistance of these wires. I just went on Amazon and I got RGB wires and didn't care what size they were. I just ordered whatever was recommended. Now what I don't understand, and I'm gonna have to do a little bit of learning here in the next couple of days to figure out what to do. What I don't understand is why the strips themselves are getting dimmer and dimmer. What you would expect to see is the same dimness for each strip. In this circuit, there's less current flowing through, but the voltage drop across each strip of lights should be the same. I understand that there's higher voltage here than there is here. So is that why? By the way, these lights are like insanely hot. Like I can't even leave my finger on for more than a second there. As much as I'm kind of annoyed and I just want to get this over with so I can start putting everything together, this has been an excellent DIY project. And even this power supply now is getting kind of hot. So I'm gonna unplug this and I'm gonna figure out why this is going on. We're gonna come back another day. I had to first figure out why I was getting results that to me weren't intuitive. I kept reading about voltage drop, but I thought that was a natural part of every circuit. This is a basic series circuit with two identical light bulbs. If I had resistance between the lights, which in our case would be the wires, the lights dim, as you might expect, but they dim equally. In series, these lights should always share the same brightness. Now here are the same lights in parallel. If I had some resistance now, there you go. Only the light downstream sees the effect. The first branch has more voltage available than the second, and same thing goes for the current. The lights being in parallel makes sense. We couldn't cut the strips otherwise and still have a functioning circuit. Now the undesired voltage drop that I kept reading about is the one that's between the branches. This voltage drop is pure energy loss, which is what's causing our problems. We can validate this in our experiment. At the beginning, where I should be measuring 12 volts, I'm only getting 10. By the end, I've got just over 6. That's a 50% loss in voltage. Ideally, we don't want any more than a few percent. So we know our problem. We have too much resistance in our system. What are some possible solutions? 1. Use thicker wires. Thicker wires carry less resistance and would allow more current to flow through. Now I looked for RGB wires that were larger than the 18 gauge ones I had, but I didn't find any. I also don't think these lights are meant for anything larger, given how tight everything seemed to be, so I was stuck with the ones I had. 2. Reduce the wire length. Right now, each set of wires is around 4 feet long, with 2 in each circuit. I could shave some of that off just by drilling more holes. Initially, I had the wires entering and exiting through the same hole. If I drill one hole on each side though, the wires can exit out the nearest hole instead of having to travel all the way back across. I calculated this would save me around 13 inches, so about a quarter of the total length, not entirely solving our problem, but still a good start. 3. Rewire or modify our circuit. Now this is a little beyond my realm, but I have heard of people doing things like adding voltage into each strip to make up the voltage losses. Maybe the circuit can be rewired to reduce some of the resistance, but I didn't consider this one too much. 4. Increase the voltage supply. We can see in our simulation that more voltage generates more power. Voltage, like pressure, is a driving force. The more you have, the more flow, or current, you can push through your system. I did some quick math just to see how much more I might need. Power is simply voltage times current, or more correctly, the voltage drop across a load times the current. These are 36 watt bulbs. With our 12 volt supply, that means they need 3 amps of current to perform properly. However, Ohm's law tells us that resistance and current are inversely related. Any increase in resistance will reduce the amount of current we could produce. Hence, we're clearly not getting the 3 amps that we need, nor are we even getting the 12 volts as we've already shown. With a higher voltage supply, we not only increase our voltage, but our current as well, since they are proportional. We can combine these two equations and see that if, let's say, we double our voltage, we should quadruple our power. It's a pretty rough estimation, but it told me that I should see a pretty substantial improvement in power output. So I went ahead and ordered a brand new set of 24 volt lights. These ones were 48 watts, so they required a little more power, but even so, I figured that with our higher voltage, reducing our wire length, and by improving our soldering techniques, that this would be enough to finally get the job done. So I just finished the soldering. I'm pretty relieved. These lights look great. Much better. They're pretty much uniformly lit. Very little voltage drop. So our theory and our research all kind of worked out. I want to measure the voltage drop just to validate that. You can see here we've got exactly 24 at the front, and then we have the end 23.9. Unbelievable. So like not even a percent voltage drop compared to probably 30 or 40% before. Better soldering technique. I spent the first couple of, I didn't record any audio today because I was kind of fed up. This kept failing. I would put my first joint on and plug it in and nothing will come on. It's so important to get these solder joints right. Cutting down the wires too. Man, this is it's pretty awesome. So now all that's left to do is install. Well, after 3 full weekends of work, I think we're finally done our project. Looks pretty sweet. I'm really happy with how this turned out. It looks super cool, especially in the dark. It's pretty neat. You can't really see anything. I mean, this is pretty awesome. Let's take a little tour here. Show you guys what I did. So the one, I guess, rough thing about this is all the electrical tape, right? These lights have very good adhesive, but the problem was I was using it to fix the lights to the table when I was soldering, because these lights were very, very hard to hold down, and the adhesive kind of helped, but you know, it wore it away. Like we talked about, we've got, and I'll show the back here once we turn on the light, but got an extension cable connected to the power supply. We run through our first set of lights, and then that cable goes down through the back, like we said, comes in, next set, boom, through the back, and fix that, and then terminates there. And same with the other shelf. You can kind of see the, you know, a little bit of green sort of discoloration. That is, again, the electrical tape, the way that it hits that black tape. It kind of gives that green colors. There's not really much I can do, but I mean, it's not really the end of the world. This is gonna look, I really like this color, and I haven't played with the remote yet, but you know, it's kind of a nice little blend with the wood. I was a little worried about that, but I kind of like, I mean, these are blue lights, right? And it's coming out purple, but I don't know, I don't mind that too much. Yeah, so with the lights on, you can, it's still kind of nice. You know, it doesn't obviously stand out as much. This is probably how it'll look when I'm filming. But yeah, it still gives it a nice little blend here. And we'll just show the back. We got our controller, or whatever you call it, that connects both sets of lights. Running up this extension cable that I had to buy because that controller it's ridiculously short. So I had to buy these two. And yeah, so one extension cable, the set of wires, and then the set of wires on the other side. And that's pretty much it. I'll, you know, clean that up. But yeah, let's turn the lights off again. Those look pretty nice. Very nice. I'm gonna clean up, and then all we gotta do is decorate it. So, ladies and gentlemen, we have our final product here. I'm pretty happy with it. Is it perfect? No. I can't change the color, for one. Believe it or not, this little toy here doesn't work. You can kind of see the lights a little bit. You can probably see some of the electrical tape. Hey, not the end of the world. It makes a difference. That's what I was going for. It makes a difference with or without the lights, get a little more color into my videos. The point of this video wasn't really to show how to best install a set of LED lights. The point was to do a project with you guys and show you what an engineering project entails. Look how many failures I had. And each time I had to figure out why I failed and fix that. And then you have another failure and you fix that and you have another failure, and you keep repeating this cycle until you eventually, hopefully, get it right. That's like almost every engineering project. Now, I have a few questions about this project that I don't have the answers to, so I'm gonna ask them to you guys. Number one, what makes a good or bad solder? It seemed like the solder joints either completed the circuit or killed it. It didn't really affect performance too much otherwise. Why did some of them work and some of them not? Is it because the solder sometimes doesn't fuse both elements properly? Is that what a cold solder joint means? In one case, when I had pretty much finished assembling everything, one of the joints started to smoke. And I was probably too embarrassed to record it, but I had to take the whole thing out, go resolder that joint, and then it worked. Why would something like this happen? Number two, why did those first lights get so hot? What I'm wondering a little more here is how LED circuits actually work. The stuff I was describing earlier was pretty simplified. In reality, LED circuits are a little more complex. They have different resistors for different colors. The bulbs are diodes, which I don't know too much about. The way a light can change its own color. Why are they designed the way that they are as opposed to, let's say, a set of Christmas lights in series? As far as the hot temperature of the lights, I would think this is just a case of energy conservation, but maybe you guys can better answer this one too. Question 3. How could I have done this project better? I don't mind drilling a dozen holes through these old ugly shelves, but if these were like brand new shelves, let's say, I might not want to obliterate them the way I did. How could I have done this in a less intrusive way? I like this project for 3 main reasons: low cost, low risk, and not a lot of skill required. I didn't have any experience with electrical stuff before this. I had no experience soldering. You guys saw how awful my soldering was in the beginning compared to the end. So don't be intimidated if you've never done this before. You do have to be a little careful, but all you really need is the ability to be able to sort of critically think, to do your research, to be patient, and to be persistent. The cost was pretty reasonable too. I think I probably spent around 250 bucks for the whole thing. Now, a lot of that is one-time purchases, right? Like the soldering iron. The lights, I would actually recommend if you're kind of serious about this, get a more expensive set. You want one where you can actually change the color. That's kind of the whole point. As far as risk goes, you do have to be careful of a couple things. I would recommend getting a holster for the iron. I didn't have one, so I kept leaving mine on the table. Had to be very aware of it at all times. Did end up burning a couple set of lights, did burn my finger. A couple times that iron gets really hot. Make sure to solder in a well-ventilated area and maybe have a fan as well. Just kind of gently blow away those solder fumes. And always make sure when you're dealing with electricity just to insulate any exposed wires with some insulation or some electrical tape. What other projects would you guys want to see? Controls would be a really cool one. I'd love to learn controls. Don't have any experience in them. Maybe PLCs, PCBs. I have an Arduino video. I have no idea how to use an Arduino. Comment below what kind of projects you guys have done. I'm kind of curious. Do me a solid as well. Subscribe to this channel if you haven't already. Leave a like on this video. Hope you guys learned something. I learned a ton on this project. It's quite satisfying. This is pretty satisfying. And yeah, maybe we'll do another one soon. So till next time, love you guys. Thank you for watching. I'm gone.